everyone, welcome to the greatest common factor and least common multiple guided notes. Let's get started. We are learning about the greatest common factor. This may also be called the greatest common divisor. The greatest common factor is the largest number that divides both numbers. We are going to determine the greatest common factor in two different ways. Let's determine the greatest common factor of 12 and 30. So you're looking for the largest number that divides both 12 and 30. Another way to write this is the GCF, and then it has parentheses 12, 30. That means the greatest common factor of 12 and 30. That's how you'll see it written a lot. We need to determine the largest number that divides both 12 and 30. One way to determine this is to write all the factors of the numbers. Let's first write the factors of 12. 1 times 12 equals 12, 2 times 6, and 3 times 4. One helpful strategy is to draw lines that connect the factors that equal that product. So 1 times 12, 2 times 6, and 3 times 4. Now write the factors of 30. So we have 1 times 30 equals 30. 2 times 15, 3 times 10, and 5 times 6. Now, looking at the factors, both of 12 and 30, what is the greatest common factor of 12 and 30? So we're looking for the largest number that is both a factor of 12 and 30. And let's see, that's going to be, looks like 6. 6 is the largest number that is both a factor of 12 and 30. So the greatest common factor of 12 and 30 will be 6. Determine the greatest common factor of 56 and 46. Factors of 56. We have 1 and 56. We have 2 and 28. 4 and 14. And then we also have 7 and 8. Factors of 46, 1 and 46. Then we have 2 and 23. So the largest common factor of 56 and 46 is going to be 2. Another way to determine the greatest common factor is to use prime factorization. So we're going to make little factor trees. It asks us to find the greatest common factor of 15 and 45. So we just think of any two numbers that are factors of 15. So I'm going to say 5 and 3. Both 5 and 3 are prime, so I'm going to stop. The factors are 5 and 3. Now I think of factors of 45, which would be 9 and 5. Now if you think of different factors, you can use those as well. You're just going to keep breaking down the numbers until everything is prime. So 9 would be 3 and 3, and now we have 3, 3, and 5, and those numbers are all prime. Prime meaning the only factors of those numbers are the number and 1. And then you write the factors down here. So 3, 3, 5. Now write all the pairs of common factors. So we have a pair of 3s and we have a pair of 5s. So a pair of 3s and a pair of 5s. The greatest common factor of 15 and 45 is the product of all the common factors listed above. So we're going to multiply those two numbers right there, and that's 15. And that is the greatest common factor of 15 and 45. Let's use prime factorization to determine the greatest common factor of 18 and 42. So starting with 18, you're just going to think of any two numbers that when multiplied together give me that number. So I'm going to go 6 and 3. 3 is prime, but 6 is not. 6 can be factored into 2 and 3. Now they all are prime. So I'm going to list the prime numbers that are factors of 18, and that is 2, 3, and 3. Now 42, two factors would be 6 and 7. 7 is prime, so I'll write that down here. 6 is not, so I'll keep going, and that's 2 and 3. And now 2 and 3 are both prime, so I'll write that down. Now write all the pairs of common factors. So we're looking for factors that are in both these lists. And that would be 2 and 3. So the greatest common factor of 18 and 42 is the product of all the common factors listed above. So I'm going to multiply 2 times 3 together, and that is 6. So the greatest common factor of 18 and 42 is 6. Use prime factorization to determine the greatest common factor of 20 and 64. So factors of 20, I'm going to go 5 and 4. 5 is prime, so I'll stop there with that one. 4 can go down to 2 and 2. 2 and 2 are both prime, so we'll add those to the list. And now 64, I'm going to do 8 times 8. That can be factored into 4 times 2, and then 2 times 2. Same thing over here, 4 and 2 and 2 and 2. So I have 2, 2, 2, and then 2, 2, 2. And that's coming from right here. 2, 2, 2, 2, 2, 2. Now write all the pairs of common factors. So I have a pair of 2's, and then I have another pair of 2's. So I have 2 2's that are common factors, there and there. So the greatest common factor of 20 and 64 is the product of all the common factors. So I'm going to multiply those together, and that gives me 4. So the greatest common factor of 20 and 64 is 4. Find the greatest common factor of the following numbers. Use either method. Greatest common factor of 30 and 40. I'm going to use the tree method on this one. So the factors of 30 are 10 and 3. 3 is prime. I'm going to keep going with 10. That gives me 2 and 5, and those are both prime. So the prime factors are 2, 5, and 3 for 30. 40 is 10 and 4. Keep going. That gives me 2 and 5 and 2 and 2. I have all prime numbers right here. So I have 2, 5, 2, 2. Pairs of common factors would be 2 and a 5. If I multiply 2 times 5 together, I get 10. So the greatest common factor is 10. The greatest common factors of 11 and 20, I'm going to do it the other way so you can see. It doesn't really matter which way. 11 is actually prime, so I'm just going to have 1 and 11. 20 is 1 times 20 is 1. 2 times 10. 4 times 5. Now I'm just looking for the largest number that is in both of those lists, and the largest number is actually 1. 24 and 32, let's do the list way again. So I'm writing down factors of 24, which is 1 and 24. And then I have 2 and 12, 3 and 8, 4 and 6, and then 5 is not a factor. For 32, I have 1 and 32, 2 and 16. 3 is not a factor. 4 and 8 are factors. And then 5 and 6 are not factors. So I am done. I'm looking for the largest number in that list that is a factor of both, and it looks like the largest number is 8. So the greatest common factor of 24 and 32 is 8. The greatest common factor of 48 and 90, we'll use the tree method. So factors of 48 would be 6 and 8. Again, if you want to use different ones, that's fine. So 6 and 8. Keep going. So that's 2 and 3. Both of those are prime. 8 would be 4 and 2, and then 2 and 2. So these are my prime numbers right here. 2, 3, 2, 2, 2. And then for 90, I'm going to go 10 and 9. 9 is going to be 3 and 3. 10 will be 2 and 5. So I have 2, 5, 3, and 3 as my prime numbers. All right, let's look at the pairs. I have a pair of 2's, and I have a pair of 3's, and that's it. No more pairs. So 2 times 3 is 6. The greatest common factor of 48 and 90 is 6. Now we are going to use the greatest common factor to rewrite expressions. Let's look at the expression 36 plus 8. Use either method to determine the greatest common factor of 36 and 8. Let's use the tree method. If you want to use the other one, that's fine. So 8, I almost have memorized at this point, but it's 2, 2, and 2. And then 36, I have 6 and 6, which both go down to 2 and 3. So my factors are 2, 3, 2, 3. The pairs of common factors would be a pair of 2's and actually another pair of 2's. So 2 times 2 is 4. The greatest common factor of 36 and 8 is 4. Now we're going to rewrite the number 36 using the greatest common factor. So the greatest common factor is 4. 4 times what equals 36? 9. And the greatest common factor, again, is 4. 4 times what equals 8? And that is 2. So we have 4 times 9 equals 36, and 4 times 2 equals 8. Now we are going to rewrite 36 plus 8 using the information above. So I'm going to write my greatest common factor here on the outside, and then the factors on the inside, 9 and 2. Basically, I'm doing the reverse of the distributive property. So I have 9 and 2 on the inside. So it is the same as 4 times the quantity 9 plus 2. Notice that these expressions are equivalent to 36 plus 8, which equals 44. And if we find the sum of the numbers in parentheses first, we have 4 times 11, which equals 44. Rewrite the expression 75 plus 10. So first we need to determine the greatest common factor of 75 and 10. Factoring 75, we have 25 and 3. So 3 is prime. 25 is 5 and 5, which are prime there. So 3 times 5 times 5. Factors of 10 would be 2 and 5. So the common pair would be 5. Let's rewrite it. So my greatest common factor is 5. 5 times what is 75? 5 times 15 is 75. And then 5, my greatest common factor, times 2 is 10. So my greatest common factor is 5. We're going to combine that and write it right here. So greatest common factor is 5. And then what's left over right here? So we have a 15 and 2. And those are going to get placed inside the parentheses. So 15 and 2. So 5 times the quantity 15 plus 2 is the same as 75 plus 10. So 15 times 2 is 17. 17 times 5 is 85, and 75 plus 10 is 85. Rewrite the expression 54 plus 18. So first we need to find the greatest common factor. I'm going to do it by making a list. So I have 1 and 54, 2 and 27. We have 3 and 18, and then 6 and 9. Factors of 18 are 1 times 18 is 18, 2 times 9 is 18, and then 3 times 6 is 18. The biggest factor would be 18, that biggest common factor. So we're going to write that right here. So 18 goes on the outside. 18 times what is 54? 18 times 3, and then 18 times 1 is 18. So 18 on the outside, 3 and 1 on the inside. Rewrite the expressions in this form right here. So what we've been doing, so first of all, we need the greatest common factor of 70 and 80. And some of these you can just think about, like the biggest number that goes into both 70 and 80, I know is going to be 10, but if we don't know that, I can write it out. So let's do a tree diagram here. So 70 would be 10 and 7, which would be 2 and 5. So I have 2, 5, and 7. And then 80 would be 10 and 8. 8 is 4 and 2, which is 2 and 2. And then 5 is 2 and 5. So I have 2, 5, 2, 2, 2. So I have a pair of 2s and a pair of 5s. Multiply those together. I get the greatest common factor is 10. And then 10 times what is 70? 7 plus 10 times what is 80? 8. So 45 is 9 and 5, which is going to be 3 and 3. So my prime factors are 3, 3, and 5. 5 is prime, so I just have 1 and 5. The greatest common factor would be 5. So I'll write that 5. What times 5 is 45? 9. And then what times 5 is 5, and that's 1. So I'm going to rewrite it like this. 5 times the quantity, 9 plus 1. Now I'm rewriting 14 plus 35. Let's find the greatest common factor of those. So 14 would be 2 and 7. 35 factored is 7 and 5, and those are both prime. So let's look at pairs there, and I have a pair of 7s, and that is it. So that's my greatest common factor. 7 times what is 14, and that's 2. Plus 7 times what is 35, and that's 5. So 7 times the quantity, 2 plus 5. 12 plus 18, let's find the greatest common factor of those. So that gives me 2 and 6, which gives me 2 and 3. So the numbers are 2, 2, and 3. 18 would be 6 and 3. 6 is 2 and 3, so I have 2 and a 3 and a 3. So let's mark pairs. I have a pair of 2s and I have a pair of 3s. 2 times 3 is 6. 6 times what is 12? So 6 times 2 is 12, and then 6 times 3 is 18. We are now going to determine the least common multiple, or you will often see it abbreviated as LCM. The least common multiple is the smallest number that two or more numbers divide evenly into. Like the GCF, or the greatest common factor, this can be determined in two different ways. One way is by listing multiples of numbers and determining the smallest common multiple. Let's use this method to determine the least common multiple of 6 and 10, or you'll see it written like this. The LCM is 6 and 10. It asks us to list 5 multiples of each number, and that's just kind of a starting point. You don't always list 5. Sometimes you'll find it sooner, or sometimes you'll need more. So we're just doing 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30. Those are multiples of 6. Now multiples of 10. 10, 20, 30, 40, 50. So now it asks us to find the least common multiple of both of the numbers. So we're just going to go through the list and look for the smallest number that is in both of the lists. And the smallest number that is in both of the lists would be 30. So that is the least common multiple of 6 and 10. Least common multiple of 8 and 6. List some multiples of each number. If there are no common multiples, then continue to list multiples until there is a common multiple. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. We'll stop right there and see if that's enough. 6 times 1 is 6. 6 times 2 is 12. 18, 24, 30. And so are there any numbers that are common in both lists? Yes, and that is 24. If I were to have continued these lists, I would have had 48. And if I would have continued this one, I would have 36, 42, and 48. So notice that 48 is also in the list as common for both of them, but it's not the smallest. You want the one that is the smallest common multiple. You can also determine the least common multiple by using prime factorization. So we need to find the least common multiple between 8 and 12. So we're going to prime factor 8. So 2, 4, 2, and 2. So 2, 2, 2. And then 12, 3, 4, and then 2 and 2. So we have 3 and 2 and 2. The least common multiple will include the factors of each number, but no extras. So let me show you what I mean. The factors of 8 are 2, 2, and 2. The prime factors of 12 are 3, 2, and 2. So if we are to combine the factors, we have the factors listed below. So if you look up here at my list, I have 2's. So we'll write those down. And I have a pair of another 2's. So we'll write that down. And then I have another 2, so I'll write that down, and I have a 3, so we'll write that down. So the pairs only get written down once, and then whatever's left over. So I have 2, 2, 2, and 3. The least common multiple is the product of the factors above. So if I multiply 2 times 2 times 2 times 3, which gives me 24, that is the least common multiple of 12 and 8. Use prime factorization to determine the least common multiple of 9 and 11. So of 9 is 3 and 3. Those are prime. And then 11 would be 11 and 1. Now let's combine the factors. So I don't have any pairs of anything. I have no common factors, so I can just really list them. 3, 3, 11. I can write 1, although I don't really have to because it's just 1. It doesn't affect it. And so now we're going to multiply all those together. So I'm going to multiply 3 times 3 times 11, and that gives me 99. Notice in this case that there are no overlapping factors. Use prime factoring to determine the least common multiple of 4 and 10. So of 4 is 2 and 2. Those are the prime factors of 4. Of 10, I have 2 and 5. So I have a pair of 2, so that number will just get written down one time, and then whatever's left over is a 2 and a 5. So I'm going to multiply 2 times 2 times 5. So 2 times 2 is 4 times 5 is 20. The least common multiple of 4 and 10 is 20. Remember to combine the factors. If there's a factor listed in both numbers, you only need to list the number one time when combining. Practice. Find the least common multiple of the following numbers. Use either method. So I will use the list on the top 2 and then the trees on the bottom 2. So multiples of 5 would be 5, 10, 15, 20, 25. I'll stop right there. Multiples of 10 would be 10, 20. I'm just going to stop right there because I noticed a number that is common in both lists, and that is 10. And so I just know the least common multiple is 10. Least common multiple of 6 and 9. Let's start listing multiples. I have 6, 12, 18, 24. I'll stop right there. 9, 18, 27. And I will stop because I see a number that is common in both of them, and that's 18. So the least common multiple of 6 and 9 is 18. Let's look at 5 and 7. The prime factors of 5 are 1 and 5. And the prime factors of 7 are 1 and 7. And so multiplying, I have no pairs that are common, so I can just multiply 5 times 7, which is 35. That's the least common multiple of 5 and 7. Let's do 10 and 12. Prime factors of 10 are 2 and 5. Prime factors of 12 are, let's see, I have 3 and 4 and then 2 and 2. So my prime factors would be 2, 2, and 3. I'm going to list any pairs one time, and then I have a 5 and another 2 and another 3. So 2 times 5 is 10, times 2 is 20, times 3 is 60. The least common multiple of 10 and 12 is 60. All right, everybody, that's it for today. Thank you.